In this example, we're going to be factoring what's called a difference of squares. So in this case, for this example, if we have x squared, write that a little better, x squared minus 64, then what we see is that this first term is a perfect square, right? Because the square root of x squared is just x, right? So that's a perfect square. X to the 4 would also be, right? Because the square root of x to the 4 would be x to the 2, right? So any even power would be a perfect square. And then on this side, 64, right? Because 8 times 8 is 64. So this is a difference, right? We're subtracting of squares. Okay, so the way we handle these is we just write our brackets down. And then we take the square root of x of the first term, so x squared. So they both factors get an x. And then we take the square root of the second term, so they both get an 8 and at the end here. But then one's minus and one's plus. And there you go. It's that easy. It really is one of the easier ones to factor. The problem is just like noticing it when you see it. So you guys just need to be on the lookout for perfect square, and the difference, right? Difference of squares. All right. Now, before I move on to the next one, let's actually just expand this out to see why that actually worked, right? So let's FOIL this. So x times x, and then x times 8, negative 8, and that one, right? So let's go x times x is x squared, and then x times 8 is 8x, and then we have negative 8 times x is negative 8x. Maybe you're seeing it. And then negative 8 times positive 8 is negative 64. All right, so that's that part there, right? Now look at this. 8x minus 8x, well, that's 0, right? So those actually just cancel. So that's what's always going to happen if you have 1 as a negative and 1 as a positive. So that would just be x squared minus 64, right? That's why it has to be a negative as well, right? Because negative 8 times positive 8 is always going to end up with a negative number. So that's why it's a difference of squares. All right. So now let's look at the next one. So I'm just going to write it again here. So we've got 4m squared minus n squared. All right. So same thing. We're dealing with all perfect squares. There's just two of them now as the first term here, but that's fine. They do both have to be perfect squares, though. Like in this case, the 4 is a perfect square and m squared is a perfect square. But we're going to handle it the same way. So let's just write down our brackets. All right, so then square root of 4 is 2, so they both get a 2. Square root of m squared is m, so they both get an m, like just right after it too, right? And then square root of n squared is n, so they both get an n. And then one's minus, and one's plus. And there you go. That's factored difference of squares. Now, actually, and just a note, it doesn't matter if this one's negative and this one's positive or vice versa, right? Either way. Okay, and then now let's look at the last one. So in the last one here, we've got 25x squared plus 81. All right, so you can probably tell by my tone there. Can we, like, here's a difference, like a perfect square is 25, perfect square, and perfect square. So you might be thinking, okay, perfect, I can do the same thing. We can't, right? That's not a difference of squares, right? So you got to be on the lookout for that negative symbol that we saw in the last ones. So in this case, this just doesn't factor. It looks really good. It looks like it should factor, but it doesn't.